In this video, we're going to be finding the Taylor series for cosine of x centered at pi over 2. After we find the Taylor series, we're going to find the radius and the interval of convergence. Because we're looking for the Taylor series, I want to remind you that f of x is equal to sigma as n goes from 0 to infinity of the nth derivative evaluated at a over n factorial times x minus a to the nth power. And this is for absolute value of x minus a less than r. Now, if our Taylor series has the nth derivative, the first thing I'm going to have us do is find the derivatives. So I'm going to do that with a table and see where that takes us. So we're going to let n be equal to 0. So we'll let it be 0, 1, 2, 3, 4, all the way to, let's say, infinity. So this will be n. And then we have the nth derivative of the function f. So the nth derivative at x. So if we're looking for the nth derivative at x, well, remember, f of x is equal to cosine of x. So when n is equal to 0, we're looking at cosine of x. And then when n is equal to 1, then we're looking for the first derivative. So we can say that f prime of x is going to be equal to negative sine of x. F double prime is equal to, the derivative of sine will be cosine, so we have a negative cosine of x. And then f triple prime will be equal to, the derivative of cosine is negative sine, and that negative, that'll bring us to sine of x. And then we have our fourth derivative. The derivative of sine will be cosine of x. And then let's evaluate at a equal to pi over 2. So f prime and the second prime, so the nth derivative of f evaluated at a. And remember that a is equal to pi over 2. So we have cosine of pi over 2 is equal to 0. We have negative sine of pi over 2 is equal to negative 1. We're going to have a negative cosine of pi over 2 is equal to 0. Sine of pi over 2 is equal to 1. Cosine of pi over 2 takes us back to 0. So it looks like the coefficients are going to be 0, negative 1, 0, 1, 0. And let me just do a few more to see what the other coefficients are going to be. So when n is equal to 5, the derivative of cosine is negative sine of x, and negative sine of pi over 2 is equal to negative 1. When n is equal to 6, the sixth derivative is going to be negative cosine of x, and negative cosine of pi over 2 is 0. When n is equal to 7, it's going to be sine of x, because the derivative of cosine is negative sine times that negative gives us a positive. And this will be a sine of pi over 2 equal to 1. So if we continue, we should have 0, -1, 0, +1, 0, -1, and then the idea will continue. If we go back and write this down, we can say the following. We can say that f of x is going to be equal to, I'm going to expand our Taylor series. If we expand that Taylor series, then we're going to say it's going to be f at pi over 2 over 0 factorial plus f prime at pi over 2 over 1 factorial times x minus pi over 2 to the first power plus f double prime at pi over 2 x minus pi over 2 to the second power over 2 factorial. But I want to remind you that when n is 2, the coefficient will be 0. When n is 4, the coefficient will be 0. When n is an even number in general, then the coefficient will be 0. So you see, when n is 0 up here too, then f evaluated at pi over 2 will be 0. So if we go back, this right here will be 0. F double prime at pi over 2, that will be 0. So this entire term will be 0. And we can say that f of x is going to be equal to f prime, let me write one more, our third derivative, at pi over 2 over 3 factorial, and then x minus pi over 2 to the third power. And then the idea will continue. So f prime at pi over 2 is -1. F triple prime is going to be a +1. So we're going to say that this is going to be a -1 over 1 factorial, x minus pi over 2 to the first, plus 1 over 3 factorial, x minus pi over 2 to the third power, minus 1 over 5 factorial, x minus pi over 2 to the fifth power. And then we'll have plus 1 over 7 factorial, x minus pi over 2 to the seventh power. And then the idea will continue. If we write this down using sigma notation, we can say we have sigma as n goes from, let's see where this takes us. It's going to be as n goes from some number to infinity. Let's talk about the alternating signs. We can say this is -1 to the, if we say to the nth power, we can then start it at 1. So when n is equal to 1, then we're looking at a negative number. And then when n is equal to 2, it's going to be a positive number. I also want you to notice that we have the denominators as 1 factorial, 3 factorial, 5 factorial, or an odd number factorial. In order for us to write an odd number, we can write that number as 2n plus or minus 1. I'm going to write it down as 2n plus 1 factorial. Now, if n is equal to 1 and you plug it in, then you have your first term to be 3 factorial, but that is the second term in the series. So rather than starting our sigma at 1, we're going to start it at 0 and see where that takes us. In terms of the denominators, when n is equal to 0, you have 1 factorial for the first term. If n is equal to 1, you have 3 factorial for your second term. If n is equal to 2, you have 5 factorial for the third term. And if n is equal to 3, you have 7 factorial for the fourth term, or 1, 2, 3 for the fourth term. All right. So we're going to start it at 0. And now we need to make sure we adjust the power of negative 1. Let me erase a couple of things. So let's go back to negative 1. Since we are now starting at 0, we're going to put negative 1 to the n plus 1. What else do we have? We are going to have x minus pi over 2 to the 2n plus 1. Okay. So we can say that the Taylor series expansion for cosine of x is this right here. I'll write it down. Taylor series expansion. And I call it the expansion because if you were to expand, you would get something that looks like that. So we have a Taylor series expansion, and this Taylor series is centered at A, where A is pi over 2. In order for us to find the radius of convergence, remember the radius of convergence, we find it when you have absolute value of x minus a less than r. Or we can say x minus pi over 2 less than r. So we're going to find the radius of convergence. In order for us to find the radius of convergence, why don't we apply the ratio test? So now we're going to find the radius of convergence. So let's take the limit as n approaches infinity of the absolute value of x minus pi over 2 to the 2 times n plus 1 over 2 times n plus 1 factorial times 2n plus 1 factorial over x minus pi over 2 to the 2n plus 1. Let's simplify this here. We're going to have the limit as n approaches infinity of x minus pi over 2 to the 2n plus 3 over 2n plus 3 factorial times 2n plus 1 factorial over x minus pi over 2 to the 2n plus 1. We can simplify that. The 2n plus 3 factorial, I'm going to do that on the side. 2n plus 3 factorial is equal to 2n plus 3 times 2n plus 2 times 2n plus 1 factorial. The x minus pi over 2 to the 2n plus 3 is really equal to x minus pi over 2 to the 2n plus 1 times x minus pi over 2 to the second. So if we simplify this, this right here, in terms of the powers, will simplify to a power of 2. And then because we are taking the limit as n approaches infinity, x minus pi over 2 to the second power will be considered a constant. So I'm going to factor that out. We have the absolute value of x minus pi over 2 to the second power times the limit as n approaches infinity of, remember, this, let me expand it. We're going to have a 2n plus 1 factorial over 2n plus 3, 2n plus 2, 2n plus 1 factorial. So we can simplify the 2n plus 1 from the numerator and the denominator, and you're left with the limit as n approaches infinity of the absolute value times x minus pi over 2 squared So x minus pi over 2 to the second power times the limit as n approaches infinity of 2n plus 3 times 2n plus 2 in the denominator. Now, remember, because we're applying the ratio test tells us that the series will converge whenever the limit is less than 1. Well, what is this limit here? This limit will always be equal to 0. Or we can say that that limit is 0. So that means that this limit will always be equal to 0, and 0 is less than 1. So because this limit will always be less than 1, we can say that there are no restrictions on x. This series will always converge. So we can say that the radius of convergence, we can say, hence, the radius of convergence will be infinity. And the interval of convergence will be from negative infinity to positive infinity. All right. So again, for our f of x equal to cosine of x, centered at pi over 2, the Taylor series is written as sigma as n goes from 0 to infinity. Let me see if I can remember. Negative 1 to the n plus 1 over 2n plus 1 factorial x minus pi over 2 to the 2n plus 1. So the center again is pi over 2. The radius is infinity. And the interval of convergence will be from negative infinity to positive infinity.